Hello everyone, continuing with the operations on matrices. In this part 2, we will be learning about the scalar multiplication of matrix, the multiplication of matrices, power of a square matrix and the matrix polynomial. First we learn about the scalar multiplication. What is the meaning of scalar multiplication? Scalar multiplication means if we are multiplying any scalar or any number to a matrix. We say let A be a matrix of order m into n and k be a number or scalar. Then k into A is known as the scalar multiplication of the matrix. Suppose we have been given matrix A as A, B, C, D, E, F. The order of this is 2 into 3. There are 2 rows and 3 columns. And we want to multiply a number k. Then we will find k into A means k will be multiplied to every element of it. So that will be k into A, k into B, k into C, k into D, k into E and k into F. We can understand this more clearly with some examples. Suppose we have a matrix A, elements in this are 2, 5, 7, 4. The order of this is 2 into 2 and we want to multiply it by 3. Then we will have 3a equal to 3 into 2, 3 into 5, 3 into 7, 3 into 4. Multiply 3 with every element of it. And then we get here, this is 6, 15, 21 and 12. We can also apply the same property for dividing the elements of a matrix. It means if we are getting anything common from all the elements, that can be taken from that particular matrix. For example, suppose we have a matrix X and the elements in this are 5, 15, 20, 30. We are finding here that every element is a multiple of 5. It means 5 can be taken common. So we can write this as 5 into, and here we get 5 1 ja 5, 5 3 ja 15, 5 4 ja 20, 5 6 ja 30. So like this we can also take a number common from the elements of the matrix. And this is the answer for this. Now we will learn about the matrix multiplication, that is multiplication of two matrices. For that we have to remember some of the condition, that is in case we have two matrices A and B and we want to find out the product A into B. Then for A into B, we should have order of A as m into n, then order of B is to be n into P. It means the number of columns in A should be same as the number of rows in B. To understand the algorithm, the first point is number of columns in A should be equal to number of rows in B. Then we have to multiply the elements of each row of A to the corresponding elements of each column of B. It means multiply the elements of rows of A to the corresponding elements of columns of B. The sum of them will give us the elements of A into B. And the third point we have to remember here is that if order of A is m into n, order of B is n into P, then order of A into B will be as m into P. It means the number of rows in that will be same as the number of rows in A. Number of columns will be same as the number of columns in B. Let's understand the multiplication now with the matrices. Suppose we have matrix A as A11, A12, A21, A22. Order of this is 2 into 2. Suppose B is B11, B12, B13, B21, B22, B23, and the order of this is 2 into 3. So we find here the number of columns in this is 2 and the number of rows in this is also 2. So we can find the product A into B. When we go for A into B, this is A11, A12, A21, A22 into B11, B12, B13, B21, B22, B23. Performing the multiplication according to this rule, we are going to multiply the first row of this to the elements of first column of this. And then we get the element here, that is A11 into B11 plus A12 into B21. This is the first element of the first row. Then we multiply the elements of the first row to the elements of second column to get the second element of the first row, that is A11 into B12 plus A12 into B22. Similarly, we multiply the elements of this to the elements of the third column, and then we get the third element of the first row, that is A11 into B13 plus A12 into B23. Then we have to multiply the elements of the second row to the columns accordingly, and we get the elements of the second row, that is here A21 into B11 plus A22 into B21, second column. A21 into B12 plus A22 into B22, third column. A21 into B13 plus A22 into B23. Like this we can perform the multiplication and find all the elements of A into B. We are finding here the order of this is 2 into 3. The number of rows 2, that is of this. Number of columns 3, that is of B. Let's learn now the multiplication of matrices by taking some of the numerical examples. Suppose we have two matrices A and B of order 2 into 2 and we want to find out their product. First we go for A into B, 1, 3, 5, 4, we write A first, then B, 3, 4, 2, 1. Then we multiply according to the rule, we multiply the first row to the first column, 1 into 3 plus 3 into 2. First row to the second column, 1 into 4 plus 3 into 1. Second row to the first column, 5 into 3 plus 4 into 2. Then second row to the second column, 5 into 4 plus 4 into 1. Finding the sum, we get here 3 plus 6, 9, 4 plus 3, 7, 15 plus 8, 23 and 20 plus 4, 24. Now suppose we want to find out the product B into A. Then we write B first, that is 3, 4, 2, 1. Then A, 1, 3, 5, 4. And we multiply according to the rule, that is 3 into 1 plus 4 into 5. First row, second column, 3 into 3 plus 4 into 4. Second row, first column, 2 into 1 plus 1 into 5. Second row, second column, 2 into 3 plus 1 into 4. Finding the sum, we get here 3 plus 20, that is 23, 9 plus 16, that is 25, 2 plus 5, that is 7, and 6 plus 4, that is 10. What we find here? Are they equal? No. So we can write here that A into B is not equal to B into A. It means we can say the product of matrices is not commutative. This can be taken as the first property of multiplication of matrices. The properties of multiplication of matrices are: number one, commutativity. If we have any of the two matrices A and B, for any matrices A and B, suppose the order of A is m into n and order of B is n into p, then A into B is possible. It means this exists because the number of columns in this is same as the number of rows. But B into A is not possible. Why? Because the number of columns in B is not equal to number of rows in A, that is P is not equal to M. It means we can say that A into B is not equal to B into A, since B into A does not exist. The second thing, in the previous example also we have seen that A into B is not equal to B into A. It means in general cases we are finding that A into B is not equal to B into A. In the previous example, we got that A into B was not equal to B into A. And hence in general cases we can say that the product of matrices or multiplication of matrices is not commutative. So we can say multiplication of matrices is not commutative. Let's go for the associativity now. The second is associativity. If A, B, C are any matrices, such that order of A is m into n, order of B is n into p, and order of C is suppose p into q, then we find that A into B into C is equal to A into B into C. This can be seen by taking some examples, and that's why we say that the multiplication of matrices is associative. Therefore, multiplication of matrices is associative. Number 3, multiplicative identity. If you remember, in the video when we were learning about the types of matrices, I told you that identity matrix or unit matrix is also known as the multiplicative identity, but it is only for the square matrices. So we can say identity matrix or unit matrix is the multiplicative identity. For a square matrix. This we have to remember because we know that identity or unit matrix is always a square matrix. So suppose we have a square matrix A, that is 2, 3, 5, 7. It is of order 2 into 2. So we have to take the identity matrix or unit matrix also of order 2 into 2. Then we say I2 is the identity matrix, and that is 1, 0, 0, 1. When we multiply A with I2, A into I2 is 2357 into 1001. And the multiplication here is 2 into 1 plus 3 into 0, 2 into 0 plus 3 into 1, 5 into 1 plus 7 into 0 and 5 into 0 plus 7 into 1. What we find? This is 2, 3, 5 and 7 same as A. Similarly, we multiply I2 with A, that is 1001 into 2357. Multiplying we get 1 into 2 plus 0 into 5. 1 into 3 plus 0 into 7. 0 into 2 plus 1 into 5 and 0 into 3 plus 1 into 7. And the answer here we get is 2, 3, 5, 7, which is also equal to A. So we find here that A into I is same as A is same as I into A, and hence we can say that the unit matrix or the identity matrix is the multiplicative identity for the square matrices. The fourth property is multiplicative inverse. Multiplicative inverse exists only for the square matrix. Why? Because identity matrix or unit matrix is always a square matrix. In case we have a matrix A, let A be a square matrix and order of A is suppose n into n, and there exists a square matrix B of order n into n such that A into B is equal to In is equal to B into A. Then we say B is the inverse of A. It is represented by A inverse. How to find out inverse of a square matrix and whether it exists for that matrix or not, we will be learning in the coming videos when we learn about the inverse matrix finding by different methods. The next property we may take for the scalar multiplication. If there is any number k multiplied to A and then we are multiplying this k into A with B, that will be same as k into A into B, and it is same as A into k into B. It means if any scalar is multiplied to any of the matrix, then the multiplication of that scalar comes to the multiplication of the matrices also. Next is the sixth one, that is distributive property. For any matrices A, B and C, for matrices A, B and C, A into B plus C is same as A into B plus A into C if the order of them is such that the product is existing. This can also be seen with the examples. Let's learn about the powers of a square matrix. Why we say that it is of a square matrix? Because to find the power of a matrix, let it be square or cube or any other power, we have to multiply the matrix to itself. And that is possible only if it is a square matrix. Suppose we want to find out A square, that will be equal to A into A, and it is possible only if A is a square matrix. This exists only if A is a square matrix. Suppose we have A as 2, 3, 5, 4 and we want to find out A square. Then we'll write A square equal to A into A, which is equal to 2, 3, 5, 4 into 2, 3, 5, 4. When we multiply, we are finding this is 2 into 2 plus 3 into 5, 2 into 3 plus 3 into 4, 5 into 2 plus 4 into 5 and 5 into 3 plus 4 into 4, which is equal to 4 plus 15, 6 plus 12, 10 plus 20 and 15 plus 16. This is now 19, 18, 30 and 31. This is the answer. So like this we can find out the square of matrix by multiplying it to itself. Now suppose we want to find out A cube. Can be found by A square into A or A into A square, because they are square matrices. We want to find out A power 4. That can be written as A square into A square or A cube into A or A into A cube. To find A power 5, we can write this as A to the power 4 into A or A into A to the power 4 and so on. We can find out the higher powers of any of the square matrix. What is a matrix polynomial? We have learnt about the polynomials in algebra also. The same way here also we can define the matrix polynomial. If A is any of the square matrix, then an expression with the higher powers of A can be said to be a matrix polynomial. So we can define a matrix polynomial as let A be a square matrix. Then the matrix polynomial PA can be written as A0 into A power n plus A1 into A power n minus 1 plus A2 into AN minus 2 plus so on AN into I. If we write AN only, then we have to multiply an identity matrix of the same order that of A with that. Why? Because these all have to be the matrices of the same order. Let's take one example to find out the value of any of the polynomial. Suppose we have been given A as the matrix and it is 3, 2, 5, 4. And we have been given a polynomial PA that is equal to 2A square plus 3A minus 5I. To find PA, first we have to find out A square. So we write A square is A into A. That is equal to 3254 into 3254. We know how to multiply. This is 3 into 3 plus 2 into 5. 3 into 2 plus 2 into 4. 5 into 3 plus 4 into 5. And 5 into 2 plus 4 into 4. This is equal to 3 3 is 9 plus 10 19. 3 2 is 6 plus 8 14. 15 plus 20 35. And 10 plus 16 26. Now we can find out the value of PA. PA is 2A square plus 3A minus 5I. We can write this as 2 into A square plus 3 into A minus 5 into I. I means we will take that of order 2 into 2 since A is of order 2 into 2. So this is 1 0 0 1. Simplifying, we are getting here 38, 28, 70 and 52 plus 9, 6, 15, 12 minus 5, 0, 0, 5. And we simplified. This is 38 plus 9 minus 5, 28 plus 6 minus 0, 70 plus 15 minus 0, 52 plus 12 minus 5. And we get the answer is 38 plus 9, 47 minus 5, 42. 28 plus 6, 34. 70 plus 15, 85. And 52 plus 12, 64 minus 5, 59. This is the answer to the problem. That is the value of this particular polynomial in terms of A. In the next video, we will discuss about the transpose of a matrix and the properties of transpose of matrix. Thanks for watching my video. If you have any comments or doubts, leave them in the comment box and I will get back to you.